Welcome to Programming for Kids with Scratch 2. I'm Mike Lehman, and thanks for joining me. This series of half-hour shows uses Scratch to introduce computer programming to kids, about 5th grade and up, and curious adults too. You'll learn all about programming in Scratch in this series. It covers loop blocks, repeat, repeat until and forever, decision blocks including if and if else, procedure blocks, variables, lists, messages, events, clones, even microphone and video webcam input. I'll create many programs including games, storytelling, drawing pictures, and programs that demonstrate important programming concepts including objects, threads, and polling. This series is all about doing and shows the creation of all working programs from start to finish. Scratch is a great first programming language and can have children very quickly creating and presenting stories and creating fun animations, all while learning valuable critical thinking skills, problem-solving skills, and the fundamentals of programming without any of the confusing and detailed syntax. Scratch presents programming commands as single blocks that are easily snapped together to make programs with very little typing. Don't let the ease of Scratch fool you into thinking that there's little here. Scratch programs can do a lot of things. Very little math is needed to make fun programs, and I give the very few equations that I'll use in a handful of about 50 challenges. Scratch is free and freely available from the highly regarded university MIT. With your web browser, you can create, share, and save your Scratch programs if you want to. You can also look online at literally millions of shared Scratch programs, and if you like, you can join the Scratch community. You can just sit back and watch this show, or you can go to scratch.mit.edu, click on the Try It Out icon, and have fun learning how to program too. All of these video challenge lessons and more are available at my programmingforkids.info website and at my programmingforkids.info YouTube channel. The countdown timer at the bottom of the screen shows how long until a program is first run. This show number 18 introduces timers and gives another list example, but with several problems that I'll troubleshoot and correct. I'll get started. In this challenge, I'll introduce timers. A timer is like a stopwatch. I can look at the timer value. I'll check timer. Notice the timer doesn't have the name of a sprite in front of it. It's shared among all of the sprites. There are variables that are unique to each sprite, like a sprite's location on the stage. You can check XY. See the cat's XY position. It shows the name of the sprite in front of the variable. Again, timer is shared among all of the sprites. The timer is like a stopwatch showing time in tenths of a second. The timer can be reset. Go to Sensing. I'll click on Reset Timer. Now the timer's been reset back to 2, 3 seconds and counting. I'll remove the timer from the stage. It might be a little distracting. I'll get the sprite's position off the stage. How can timers be helpful? Imagine I have a game with a car driving back and forth across the stage. I want a time limit for the game. I'll use a timer for that. I'll choose a backdrop, new backdrops, scroll down, Night City with street. I'm not going to use the cat. I'll delete the cat. Get a new sprite. I'm going to want a car. I'll use the convertible here. Bring it onto the road. Might look a little better. I always want the car to start in this position. I'll get Go To and Events when the green flag is clicked. I want the car to go back and forth across the stage. Something real simple. Go to Control. I'll use a forever loop. I want it to move, motion. Move 10. I'll make it a little bit slower. I'll move 5 steps. I'll try it. Stop and run. Well, it didn't bounce back, did it? I'll stop it. I'll add if on edge bounce. I'll try it now. Stop and restart. Well, that's not too good. I'll stop the program. I want to initialize the rotation style. Set rotation style. Left, right is what I want. I'll try again. Stop. Start. See if it bounces correctly now. Good. It's bouncing back and forth. I'll stop it. Imagine this is part of a game, and a game has a time limit to end the game. For this simple example, I'll use a short time limit of 5 seconds. First, I'll add a couple simple arrow commands so I can pretend it's a game. I'll go to Events. When space is clicked, I'll use the arrow keys. If the right arrow is clicked, I'll go to Motion. Point in direction, 90 should be right. 90 should be right. It's to the right. That's right. I'll duplicate this. If I use the left arrow, I want to go to the left, negative 90 degrees. Give this a try. Stop. Run. Left arrow, right, left, right, left, right. Working nicely. And it bounces back when it needs to. I'll stop it. Now I want my program to run for a time limit instead of forever. How can I use the timer to do this? I can save the timer value just before the start of the loop. Then, no matter what time it is, I want to stop when the timer value is 5 seconds larger than when I started at the top of the loop. Notice that I don't need to reset the timer. I'll want a variable, data, make a variable. I'll call it end time. For all sprites, okay. I want it to be 5 seconds larger than the timer value. I'll set end time right before I enter the loop. Operators, plus 5. I need the timer value, timer. Now end time will have the value of timer plus 5. I can't have my loop run forever now. I'll get rid of that. Go to Control, repeat until, put these back in. I want to repeat until the timer value is greater than end time. When timer is greater than end time, timer has gone past 5 seconds and I'll finish my program. Operators, greater than, repeat until timer is greater than end time. I'll duplicate timer, data, end time, repeat until timer is greater than end time. Now when the green flag is clicked, the car is positioned on the left side of the stage on the street, has the correct rotation style. End time will be set to whatever the timer value is plus 5 seconds. The loop will repeat until the timer value is incremented to be greater than end time. While it's running in the loop, the car will move 5 steps, bounce when necessary. Keep doing this till it's finished. I'll have it display a message when the game is over. Looks, say, game over. And I'll move end time over here in the middle. I'll run the program now. Make sure it's stopped. Start. It's going. I can use the arrows, left and right, and the timer stops the game. I'll go to Sensing. It's very important to know that resetting the timer sets it back to 0, the value it starts with when the green flag is clicked. If my car sprite resets the timer, the new values must work properly for all sprites that might be using it. I'll show this in another challenge. I'm finished with this challenge. I encourage you to play with this program and get experience working with the Scratch timer. Try changing the program. Try making the program run 3 seconds longer while it's running if the 3 key is pressed. Try having the program end immediately if the Q key is pressed, Q for quit. Try changing the program so that instead of showing the end time variable on the stage, it shows the remaining time when the program will end. It'll be good enough to create a new variable, set it to the amount of remaining time, and show it on the stage. Be sure to show the remaining time of 0 when the loop is finished so the program doesn't have a small non-zero remaining time at the end. For a big challenge, make a new program that displays multiple choice questions and waits up to 5 seconds for an answer. The answer would be 1, 2, 3, or 4. Do not use ask and answer because ask blocks until an answer is given. Instead, use events when keys pressed for 1, 2, 3, and 4 keys, like this program. Also, end a loop immediately when an answer is given. They shouldn't have to wait for a timer to see whether the answer they entered is right or wrong. And when the loop finishes, let the person know whether they got the correct answer. I hope you get comfortable with timers and have fun with this program. My challenges have gone pretty smoothly so far, focusing on a particular topic, lists, variables, loops, procedures, and such. On this challenge, I'll hit a problem or two, so try to see the errors before they happen. On this challenge, a shopper has several items in a basket. The items will be removed from the basket one at a time and added to the shopping bag. The basket and the shopping bag will be lists. For fun, I'll put some sprites on the stage with a backdrop, but not for the items in the lists. This challenge focuses on lists and fixing problems. The program's finished when all the items have been removed from the basket list and added to the shopping bag list. First, I'll select a backdrop and create a few sprites. I'll select a new backdrop, indoors, room 2. I'm not going to use the cat, so I'll delete him. Right-click, delete. I want to add some sprites. New sprite, people, girl 2. She'll be the cashier. I'll change her name. Go back to the sprite list. I'll get another sprite, new sprite, people. I'll get boy 1. He's the shopper. Change his name. I'll get one more sprite so the store has a counter for the cashier. New sprite, things, button 3. I'll call it counter. It's the counter in a store, it's not counting numbers. Button's too small to be a counter. I'll make it larger. I'll go to looks, set size. It's 100 right now. Try 200%. Click on it. Bigger, a little too small. How about 250%? Run it. That'll be a good size. I'll put the counter in the middle. And I want the cashier closer and behind it. But now the cashier is in front of it. How can I get the cashier behind the counter? I'll go to my sprites list, click on the counter. I want the counter to be in the front. I'll get go to front. When I click on it, the counter becomes a top layer of the sprites. I'll make sure the cashier is behind the counter. I'll have the cashier go back one layer. I'll get when the green flag is clicked, events. When the green flag is clicked, the cashier will be back one layer. I'll go to block help, see what go back means. Go back is used to go back a certain number of layers. These visual layers of sprites tell Scratch how to stack the sprites on the stage, so a sprite can be in front of another sprite or behind another sprite. I'll close this, go back to counter. When the green flag is clicked, save the size, and have the counter go to the front. I'll move the shopper over, but I want the shopper facing the counter. I'll go to motion. I can tell the shopper to point in the left direction. Right now the shopper is pointing to the right. Point to the left, run it. The shopper is pointing to the left, but he's upside down. I'll have to fix the rotation style. This is already set for the right rotation style. I'll get events. Green flag clicked. I'll click on it now. You can see that the shopper is pointing in the right direction. I've got the sprites where I want them. I'll go to motion. Get the XY for the shopper. Go to the counter. Get the counter's XY. The cashier. Get the cashier's XY. Now I can move these sprites anywhere I want, run the program, and they're set up on the stage correctly. I've got some sprites on the stage now that really don't do anything, but do give me a chance to show go to front and go back. I'll create the basket and shopping bag lists now. Go to Data, make a list, basket. I'll leave it for all sprites, okay. Move it over. Make a list, shopping bag. Okay. Move it over. They're a little big right now, but I'll resize them later. I want the stage to initialize the lists. Go to Stage, make a procedure block, make a block, initialize lists, no options, okay. When the green flag is clicked on, I'll call initialize lists. Initialize lists, go to Data, we'll empty the shopping bag, delete all, duplicate, do the same thing for the basket. Now they're both empty. I'll add some items into the basket. Changed basket. I'll have apples. Duplicate. A couple more. After apples, broccoli. Carrots. And zucchini. I'll click on the green flag, and my basket has the 4 items now. Make it a little smaller. I can make the shopping bag the same size. I'll put it there. It looks like about the right size. Okay. I want to take an item from the basket and put it in a shopping bag. Seems reasonable the cashier would be doing this. When the space key is pressed, Events, Space. First I'll remove a random item from the basket. I'll go to Data, Delete. I'll get a random item from the basket. I want to delete from basket. I'll need a random item. I'll get Item. Can choose Random. Basket. Random item from basket will give me broccoli or apples or carrots or whatever. I'll put that in. Will this work? I can try it a couple times. Stop, green flag. Press the space key. Nothing was removed. I'll press the space key again. Nothing was removed. It doesn't work. Why is that? I'll go to Block Help. Help on Delete. Deletes one or all the items from a list, but it wants the position in the list, not the item. It makes sense. If an item, say apples, were in the list more than once, Delete might not delete the desired item. By specifying the position in the list, I know for certain which item will be deleted. I'll close Help. I'll get Item out of Delete. I'll need to choose a random position in the basket list. Operators, pick Random. I'll go back to Data and get the length of the basket. Right now, Pick Random will choose a random number, 1, 2, 3, or 4, and that item will be deleted from basket. I'll try the program. Stop, green flag, spacebar. Zucchini was removed. Apples were removed. Carrots were removed. And broccoli was removed. That part's working nicely, but I need to get the food into the shopping bag. I want to add the item into the shopping bag. Block Help. Add. It shows that Add doesn't take a position. It actually takes the item to put into the list. A little different than the Delete block. Close it. I'll copy Pick Random. I don't want the random number. I want the item at the random number. And Add. Now a random item number is picked out of the basket and put into the shopping bag. Do I want to do the add before or after the delete? I'll need it before the delete after the delete is too late. Is this good? See any problems? I'll try it. Stop. Reinitialize, green flag. I'll press the space. That didn't work quite right. I've got broccoli in the shopping bag. The carrots are missing out of the basket. I still have broccoli in the basket. This isn't working right. Why is that? Do you see the problem? Add gets a random item, and delete gets a random item, but delete and add need to have the same item. Delete's pick random will very likely be different than the pick random used by add. I need a variable to hold the random item's list index value and have add and delete use the variable's value. I'll make a variable. I'll call it my index, only for the cashier. Okay. Move it under the counter. I'll set it to the random pick. Set. Pick random. I don't need this pick random now. My index has the random pick. I'll get my index for add item, and my index for delete. Now when the space bar is pressed, my index will be set to the random pick. That item in the basket will be added to the shopping bag. Then that same picked item will be removed from the basket. Does this program have any problems? I'll try it. Stop. Green flag. Basket looks good. Shopping bag looks good. I'll press the space bar. My index is 4. Zucchini was removed from the basket and put into the shopping bag. I'll press the space bar again. My index is 2. Broccoli, number 2, was removed from the basket and put into the shopping bag. Space bar. My index is 2 again. That was carrots. Carrots are now in the shopping bag and not in the basket. One more time. The basket's empty and apples are in the shopping bag. Program seems to be working nicely. We're done. Or are we? What's wrong? What if I press space one more time? What will happen? I'll press the space bar. Nothing was removed from the basket. There wasn't anything to remove. Now the shopping bag has 5 items. It has an empty item added to the end. There wasn't anything to delete. That wasn't a problem. But when the space bar is pressed, this handler is going to add something to the shopping bag. Is that right? The handler shouldn't always add something into the shopping bag. It doesn't make any sense to do this when the basket's empty. How can I change the code to get rid of this bug? I only want to perform these actions if the basket is not empty. I'll go to Control. If the basket is not empty, then do the add and the delete. Go to Operators. If the length is greater than 0, I'll go back to Data. I'll get length. If the length is greater than 0, I'll set my index, add an item from the basket to the shopping bag, delete the item from the basket. Is this right? No, not quite. Length of basket. Okay. Do you see anything else wrong? I'll try it now. Stop. Green flag. Basket's initialized correctly. Press the space bar. First item, apples, was removed. Good. Then zucchini was removed. Carrots and broccoli. I'll press the space bar again. No change. Shopping bag is still 4, and I can keep pressing the space bar. No change. That's acting nicely. How do I know when the program's correct? This brings up a very important and deep question. How do I know when the program doesn't have any bugs? At a minimum, it must do everything it is supposed to do. It must meet its requirements. I've been making this program as if I had these informal requirements. The program shall start with an empty shopping bag. The program shall start with at least one item in the basket. When the space key is pressed, and the item shall be removed from the basket. And the item that was removed from the basket shall be added to the shopping bag. A program needs to meet its requirements, but trying to list all requirements can be exhausting if not impossible. We're assuming many requirements right now. The deployment environment, the program is in Scratch. The intended audience, the program is in English. How the program should be seen. The item seen on the stage should be of a reasonable size, whatever that is, but if we make it a requirement, it must be testable. Performance requirements. What if it takes an hour or 5 minutes or 5 seconds to update the lists when the space key is pressed? We've seen it happens very rapidly. We would want it to happen that way. What about functional testing? What if I need to start with 100 items or 1,000 items? Am I certain the program would work with that many? I'll leave it at this point for testing. Testing is a large, critical, and necessary topic. There are many levels to testing. For this series, I'll focus on meeting requirements, what the program is supposed to do, and testing boundary cases. Cases where data values are at the edges of decisions, of if statements, if-else statements, and loop iterations. This challenge started off innocently enough, but after being dragged through various errors and corrections, it ended with a glimpse of what makes a program correct. Keep in mind that when programs don't work right, make sure you're using the command blocks correctly, and get more data of what is happening to help you determine what is wrong. Also, always keep in mind what the requirements are, what it is that you're really trying to create. But above all, focus on understanding the problem and solving it. Don't be distracted by negative feelings for the program not working right. The sooner the program's fixed, the sooner the negative feelings will go away. Fix the problems and learn where you need to improve to help avoid repeating the problems in the future. Improve how you program. As always, play with the program. Get comfortable with lists. Try changing the program. Have the program keep a cost of each item and determine how much the shopper needs to pay. Have fun with it and learn from your mistakes. I'm glad you could join me. You can review these and all of my challenges at my programmingforkids.info website and on my programmingforkids.info YouTube channel. I encourage you to try the things you've just learned and explore the extra challenges I've suggested. I hope you can join me for the other shows. Until next time, have fun being creative.